Okay, one thing I want to recommend is that when you're looking at a problem and you don't know what to do, I'm not saying this is the best way to do something. It's just the way I see how to do the problem initially. So when I looked at this thing over here, I got to be honest with you, I was hoping to see a pattern in the problem. And someone says, what pattern are you hoping to see? I'm hoping to see something. So one thing I want to recommend to you is that just to rewrite the problem so maybe things get a little bit better. So what I did was I just simply started to rewrite the problem over again. So I saw this, right? And then what I did was I took this over here. I see that. I see this, and I see this. And then what I did, I started to myself, maybe it's something to do with perfect squares. So what I did was I rearranged the problem so the squares were on one side. All right? So I want to point out what I did over here. Let me get my eraser out. No, that's not an eraser, is it? So I saw this square here and this square here, and I just put them on one side. And why is that? I see the difference of perfect squares then, all right? And then I would take the other two terms, put on the other side. And by the way, it could be a dead end. And a lot of times, you know what? It is a dead end. It's not there. There's no pattern there, all right? But I'm looking for a pattern. So I think I see a pattern on the left side, and that's the difference of perfect squares. So it'd be 3x minus 2a plus 2 times x plus 4a, 3x minus 2a minus 2 times x plus 4a. I wrote that down. Now, I look at this side also and hope there's a pattern over there. And kind of looking at it, what I notice is that, well, there is 4x common between those two terms. So I pull it out. And then what am I left off with? 2 times that and this over here. Then I start to simplify things. Let me get my eraser out, and I'm going to talk about the simplifications now. The first simplification I do is this one over here. And I think to myself, it's really not that bad. It's 3x and 2x, which is 5x. Minus 2 plus 8 is plus 6a. Again, this could still be a dead end. What do I see next? 3x minus 2x, which is x. Minus 2a minus 8a is minus 10a. Well, at least it's simplified. What do you get the other side? You get 4x. Let's do this. 2x and 3x is 5x. 4a minus 2a is 6a. By the way, things are getting easier as I move along. And what I mean by that, I'm at this line now. Now, when you're studying answer key, this is what you're looking at now. You're looking at this. What do I notice? Immediately I notice that there's the same factor on each side. So to simplify the problem, I'm going to say to myself, well, gee whiz, 5x plus 6a could be 0 because it would satisfy that equation. So what does that mean? 5x is minus 6a, and then I would get x equals minus 6a over 5, all right? And then what do I do? Basically, you're back to a really simple equation now. I'll write it down for you. That's what you get on the left side if I divide both sides by 5x plus 6a. What do you get on the right side? You just get 4x. By the way, I realize something is being done over here differently. All right, but it's really equivalent. It's really the same thing. What do I do over here? Well, minus 10a is equal to 3x. And then what do you get over there? Minus 10a over 3 is equal to x. So I got my two solutions over here. What's two solutions going to be? X equals minus 6a over 5, and x equals minus 10a over 3. And both will work. If you want to go back and check that, you can. Just substitute it in. It's really not that bad. Again, over here, I want to point out what I did over here. Over here, what I did instead, zero product rule, subtracted 4x times 5x plus 6a, factored the problem, and I got this over here. I'm really saying the same exact thing, by the way. No difference, all right? Stuff that we've seen before, stuff that we're familiar with. Thank you.